Warp drive, imagining the impossible. The vastness of space has always captivated the human imagination. For centuries, we've looked up at the stars and dreamt of exploring distant galaxies, but the immense distances involved make this a daunting challenge. Light itself, the fastest thing in the universe, takes years to reach even our closest stellar neighbours. This is where the concept of a warp drive comes in, a revolutionary idea that has become a staple of science fiction, most notably in the Star Trek universe. A warp drive, if realised, would allow us to travel faster than light, not by breaking the cosmic speed limit, but by bending the fabric of space-time itself. Imagine a surfer riding a wave. The surfer is propelled forward by the movement of the wave beneath them. Similarly, a warp drive would create a warp bubble around a spacecraft, compressing the space in front of it and expanding the space behind it. This distortion of space-time would propel the spacecraft forward at incredible speeds, potentially allowing us to traverse vast cosmic distances in a fraction of the time it would take at conventional speeds. But how close are we to turning this science fiction dream into reality? The answer, unfortunately, is not very close. While the concept of a warp drive is theoretically possible within the framework of Einstein's theory of general relativity, the technological and scientific hurdles we face are immense. We'll need breakthroughs in our understanding of physics, the development of entirely new technologies, and potentially even the discovery of new forms of matter and energy. The journey towards warp drive is a long and arduous one, but the potential rewards, the opportunity to explore the cosmos and unlock its secrets, make it a journey worth pursuing. The Alcubierre drive, as it is now known, remains a theoretical concept, but it provides a mathematical framework for how a warp drive might work. Alcubierre's solution involves creating a region of space-time where the space-time metric, a mathematical construct that describes the geometry of space-time, is warped in a specific way. Imagine a flat sheet of rubber representing space-time. Placing a heavy object on the sheet causes it to sag, representing the warping of space-time by gravity. The Alcubierre drive, however, requires a different kind of warping. Instead of a simple sag, it requires a specific distortion, where the space in front of the spacecraft is contracted, while the space behind it is expanded. This distortion would create a wave of space-time that would propel the spacecraft forward. The spacecraft would be at rest within its local space-time bubble, while the bubble itself would be surfing on this wave, moving faster than light. Section 5. Exotic matter. The key to unlocking warp drive. While the Alcubierre drive is theoretically possible, it comes with a significant caveat. To create the necessary warping of space-time, we would need a substance with very peculiar properties, known as exotic matter. Exotic matter in this context refers to matter that has negative mass-energy density, a concept that is not well understood and has never been observed in nature. Negative mass-energy density would essentially mean that the exotic matter has negative mass and exerts negative pressure. This is counterintuitive to our everyday experience, where mass is always positive and pressure pushes outward. Negative mass, if it exists, would behave in the opposite way, being repelled by gravity rather than attracted to it. This exotic matter is crucial for the Alcubierre drive because it would allow us to create the necessary warp bubble. The negative mass-energy density of the exotic matter would cause space-time to expand behind the spacecraft and contract in front of it, creating the warp effect. However, the existence of exotic matter remains purely hypothetical, and even if it does exist, we have no known way to create or manipulate it. Section 6. Energy crisis. Powering a warp drive. Even if we could overcome the hurdle of exotic matter, the energy requirements for a warp drive are another major challenge. The amount of energy required to create a warp bubble is staggering, far exceeding the total energy output of our Sun. Initial calculations suggested that the energy required to create a warp bubble would be equivalent to the mass energy of Jupiter, an enormous amount of energy. However, subsequent research has shown that by optimizing the shape of the warp bubble, the energy requirements could be significantly reduced, potentially down to the mass energy of a few tons. While this reduction in energy requirements is encouraging, it still poses a significant challenge. To put this into perspective, the largest particle accelerator ever built, the Large Hadron Collider, can only achieve energies equivalent to a few trillion electron volts. To create a warp bubble, we would need energies on the order of billions or even trillions of times greater than this. Section 10. Conclusion: a future among the stars. The dream of warp drive, of traveling among the stars and exploring the vastness of the cosmos, is a powerful motivator for scientific inquiry and technological innovation. While we are still a long way from realizing this dream, the journey itself is just as important as the destination. The pursuit of warp drive will continue to inspire generations of scientists and engineers, pushing us to expand the boundaries of human knowledge and explore the universe in ever more profound ways. And who knows, perhaps one day, far in the future, humanity will finally unlock the secrets of warp drive, opening up a new era of interstellar exploration and ushering in a future among the stars.